This is AutoAlign, the automatic part correction system in Augmentus. In this walkthrough, we'll set it up end to end, from a reference scan to a corrected robot path. In production, a workpiece rarely sits in exactly the same place twice. Even a small shift from its reference position is enough to send a fixed robot path off the part. AutoAlign corrects for that deviation automatically on every run. Before you begin, 3 things should be in place. First, sensor calibration must be complete, both hand-eye and eye-hand calibration, so the scanner and the robot share one frame of reference. Second, choose a reference object with distinct feature-rich geometry. Flat or symmetrical parts give the registration too little to lock onto. And third, you'll need a reference mesh, captured from an earlier scan that covers as much of the part as possible. The workflow has 5 steps. First, set the scan parameters. Capture a reference with scan for AutoAlign. Change to your end effector. Apply AutoAlign to correct the path. Then check the results. Let's walk through each one. Start by creating a project built on the workpiece's reference mesh. Choose the scan you captured earlier as the model. With the project ready, open the correction menu and add 2 modules, Scan Parameters and Scan for AutoAlign. In Scan Parameters, tune the laser exposure and frame rate to your surface. Use higher exposure for dark, matte parts and keep the frame rate matched to the robot speed so the scan captures enough detail. Next, configure the scan for AutoAlign module. This defines the reference region the software aligns against. Use the 3D mesh crop to draw a boundary box around a feature-rich section of the part, and keep the background out of the box. Noise like the table surface pulls accuracy down, so crop tight to the workpiece. Then set up the scan pass. The key scan waypoint fixes where the pass begins, so jog the robot to it and update. The size sets the scan length, just a little longer than the target surface. The robot speed controls how fast it moves. With everything set, generate the scan for AutoAlign. Before running the process, add a change tool function to switch the active tool from the scanner over to your end effector, here the sanding tool that follows the corrected path. The process path itself has already been generated with AutoSurface and the Path Optimizer. To make that path adapt to the part, we apply AutoAlign on top of it. Add the AutoAlign module from the correction menu and wrap it around the target path between a start and an end, so the correction only affects the path inside. In the properties, edit the correction limits, the largest translation and rotation the path is allowed to shift. Here, we set 10 millimeters on X and Y, comfortably above the part's expected movement, but tight enough for reliable correction. Now turn AutoAlign on and send the job to the robot. It takes a fresh scan of the part, registers it against the reference mesh, and adjusts the path on the fly to follow wherever the part actually sits. On the cell, the robot moves across the workpiece, sweeping the scanner along the planned path to measure exactly where the part sits right now. When the registration finishes, the result window opens. The delta table reports the detected deviation on every axis against the limit you set, and marks each one pass or exceeded. Here, the part shifted about 6 millimeters on X and 4 on Y, both well within the 10 millimeter limit, so every axis passes and the corrected path runs. The same part, in 2 different positions between runs. AutoAlign rescans, measures how far it moved and corrects the path to follow it. No reteaching. With the path corrected, the robot runs the process on the part, following the adjusted toolpath exactly where the workpiece now sits. And that's AutoAlign. Define a reference, set your correction limits, and the robot aligns itself to the part on every run, with no reteaching when the workpiece moves.